Hello and welcome to yet another Focus Chat. I'm Alex Bolboaca and I'm not in the Mozaic Works studios this time. I'm in another location. So we'll have a bit of different conditions for our chat today. I hope you'll enjoy it nonetheless. The topic for today is architecture upfront design, and how much upfront design should we do? There's a lot to discuss here, and in order to get to the bottom of this issue, I have with me, as usual, Adi. Hi.
Hello.
All right, so before we go, we have an article written by Simon Brown that we'd like to go through, but I guess the question is, before we start, what is your experience with upfront design and big design upfront?
This was always a discussion about how much upfront design we need to have, and I think in my experience, I always said that you need some upfront design, and that idea that now we're agile and we don't care about design anymore is just doesn't make sense. We do need some design up front. We don't need big design up front. We need some design up front depending on what we are doing and depending on many circumstances. And that's why I'm happy that Simon documented in a way these ideas.
My experience has been working with teams. So back when I was working in outsourcing, many customers would come with long-term projects, things that would take like 1 year, 2 years, things like that. And typically the planning for these projects will start by saying, okay, we'll build a framework first. And every single time a team has started by building a framework, everything went really bad. Because, and I guess I learned in time, the skills for designing a framework are very different from the skills of designing something that is actually used by somebody.
And designing a framework without having it used, it's really difficult.
Exactly, and that's the other thing. You can design a framework by extracting it from a number of use cases. And this has been fundamentally a shift in my mindset after I've seen this happening again and again and again. And then I've met the XP bunch, J.B. Reinsberger, Corey Haynes, and a few other people who show me that you can actually obtain design by removing duplication, by naming things, by doing it incrementally. So you do little by little. However, this doesn't mean that you don't need some upfront design, particularly when you have more people and more teams working together. I think this is, in general, when you need some strategy, because otherwise you want to go fast, you want to benefit from working with multiple teams or with more people, but if you don't have some skeleton, a set of rules that you follow, some constraints, things will go very quickly down the drain.
Yes, exactly. So upfront design can mean many things. It can mean also just some guidelines for architecture and maybe for design. It can mean having a part that is mandatory to be used in such a way because circumstances, like, I don't know, you need to integrate with something. I can give you an example from one of our customers that they needed to integrate with Amazon, and if we integrate with Amazon, you need to respect some sort of rules, like with their platform, with their open platform. So again, if you want to be part of that club, you need to respect some rules, and that's a given. You cannot do anything else but respect those rules, and so on. So that's these are some things you need to respect sometimes because outside circumstances, and that's those are the constraints that we need to look at, and we need to take care of them through this upfront design. But you shouldn't go that far away, as you mentioned, with the framework, so that you have something that's extremely deep, and you go into the features and you consider that you need more than you actually need.
Yeah, and this was the other thing. Let's make a framework that's flexible enough to work for the future projects as well.
Mm-hmm.
It's very, very difficult to do that. Almost impossible, because future changes. You cannot actually predict the future. And so you end up with something that is so open to all kinds of things that it is very complicated, very difficult to use, and it tends to be very buggy. Or due to the complexity, you have to test it a lot. One of the two things. I guess if I were to do a framework today, I would do it using test-driven development and having 3-4 use cases. That would be the way I would do that if I would have to start with a framework.
Mm-hmm. And let's face it, you don't need to start with a framework that often. That's typically a mistake. Sometimes you do need to do that, but it's a lot less than the majority, or it's even a great minority in cases.
Yeah. I also would like to mention domain-driven design here, because many people use domain-driven design as big design upfront.
Mm-hmm.
And this can be a problem. I mean, sure, maybe you can understand the domain, and that helps you set some things, but you'll always understand the domain slightly wrong.
Mm-hmm.
Your understanding will improve in time, and if you don't adjust the domain model to your understanding, you have technical debt, the real, let's say, the core idea of technical debt.
Exactly. You don't encapsulate the knowledge that you uncovered through developing and using that system. You don't encode it into the system itself. So you are more and more out of sync with what you know and what's encoded in the code of what you have.
Yeah, exactly. All right, so let's see what Simon Brown has to say about this. I think this time I will let you read because of our
setup. Yeah.
Setup.
Apparently, Simon has 5 rules, and I think every one of these is a blog post. But we won't go into each one of them. I think we'll just go through these 5, and if you'll find it interesting, we encourage you to read in detail what Simon has to say. Says that software architecture has traditionally been associated with big design upfront and waterfall style delivery. So that's typically the case. And then the Manifesto of Agile Software Development suggested that we should value responding to change over following a plan. And that's the idea, I guess, with this software architecture isn't about big design up front, which the Agile Manifesto comes, but I guess also XP a lot before that had this in plan and wouldn't do big design up front. One of the people whom I know were part of XP, if I'm not mistaken, Dave Thomas, says that big design up front is dumb. Doing no design up front is even dumber.
Yeah, there was at some point, I remember Rebecca telling me that at some point there was this current of thinking that architecture will emerge from your code. And yes, this can happen. Architecture can actually emerge. The problem is the speed. and how correct it is. Because if it emerges based on the constraints that you have at that time. Whereas if you do a proper analysis of architecture beforehand, you take into account a bunch of non-functional constraints and so on. So it's much more, it typically tends to be more structured and a better solution. But the other thing is, if you want to emerge architecture, the way to do that is by extracting modules and refactoring modules and so on at all times. And this is a very costly and slow process.
Mm-hmm.
It's not as easy as refactoring code that's inside the class or inside 3 classes.
And it doesn't make sense to have this type of emerging architecture when you are almost sure what you need to have. But it does make sense when you are almost unsure what you need to have.
Yeah, and I think that's where XP is slightly different from the other approaches, because the goal of extreme programming is to offer you a way of working in a very unpredictable environment.
Mm-hmm. So that's why you have the architectural spikes, right?
Exactly. So you have all these kinds of methods where you have spikes. You don't have fixed sprints. You have iterations that are of various lengths depending on what you're doing at that point in time, and so on. Everything adapts to the speed of change around you. And that's what extreme programming is about. But if you're doing, let's say, a more enterprisey project that's used inside an organization that already has 10 different systems and you need to integrate with those, it's, you kind of know what the architecture will look like.
Yeah, exactly. So that's what Simon is saying here, that there's a sweet spot between relatively easy to discover what you need up front, and put this what you need up front as a starting point and setting a direction to the team. But this brings a lot of value, but it doesn't mean to be that prescriptive or that far away, right?
Mm-hmm.
Here it says that, gives another quote from Grady Booch, that architecture represents the significant decisions where significance is measured by cost of change. So this is about significant decisions that we need to take. And Simon says, in other words, which decisions are expensive to change at a later date. So this is what you need to take into account. Because if you take upfront decisions that are expensive and you're not sure about them, or you think you're sure but you didn't test them, maybe you shouldn't take those decisions upfront.
Yeah. So it's interesting to see this from Grady Booch. I'm teaching often a course on, well, 2 courses on software architecture. One is from developer to architect, for developers who want to become or are interested in architecture. And the second one is software architecture principles, that is more advanced. And one of the parts of the course is to figure out a definition for software architecture. And actually there is none, because but we can have a bunch of statements, and this is, architecture is about significant decisions. The thing is, significance is not always cost of change.
Mm-hmm.
So cost of change can be a very important part of architecture, but is not the only one. Imagine you're doing some kind of AI algorithm for Google. Sometimes performance is the most important part. Other times security is the most important part. Cost of change is always there up to a level, but you actually have much more different and much more varied architectural constraints. Mm-hmm. But yeah, it's a good it's an article and it's a short one, so he couldn't go into so many details.
Yeah. So a bit further, it says if you're building a monolithic software system, the choice of programming language is likely to be significant for a number of reasons. Adopting a microservices architecture potentially reduces the significance of which programming languages you choose, but introduces other trade-offs that you need thinking through. So that's the idea. That's one choice of how to make sure that you can reduce this or minimize some of the initial decisions or minimize the risk, but there's also a payoff. So that's typically the idea. And that's what we are discussing typically with architects, that especially architects who are newer to this and are doing more programming are a bit surprised that you need always to take a trade-off, and there's never the best solution. Which is the best tool for?
Yeah, Mark Richardson and Ned Price have written a book, actually 2 books of software architecture, but they have a chapter on, I think, laws of software architecture or something like that. The first law is you always have a trade-off. The second law, the corollary, actually is if you don't see a trade-off, it just means you don't see it. It doesn't mean it doesn't exist. Mm-hmm. Every architecture decision is a trade-off. You just need to train yourself to figure out what it is. Yeah. Mm-hmm.
Yes. Then says adopting a hexagonal architecture allows you to decouple your business logic from your technology choices. But again, there are trade-offs. So everything what we do that's very important is trade-off. And I think we also discussed a few weeks back about the ideas of Chris Metz around real options. And this applies very well here, because if you have an option in the beginning of something, or you have a few options in the beginning of let's say these 3 choices, and you decide on one of them, you don't take your time to analyze, it means that you killed all the other decisions. At one moment you will need to take the decision, but you can defer that until you have enough data.
Yeah, and you can defer a number of things. You can defer persistence, you can defer depending on what your constraints are. Mm-hmm. That's why it's very important to figure out for architecture what your concerns are. And this is a strategic endeavor. That's the thing. It's something that will affect many people over a long period of time. Yeah. We see this a lot with C++ programmer, right? Many of them are working on code bases that are 10, 20 years old. And some of those decisions that somebody made 20 years ago are still in the code base today. Mm-hmm. It's incredible.
Yeah. So I see this as the XP way of trying to defer the decisions, as very connected with what Chris Metz is saying about real options, so that you need to take those decisions up front that make you able to start depending on your conditions and your constraints, and you need to start spiking in order to understand which are what decisions you can take. And by spiking, I mean to have small experiments to understand which solution is better for whichever of your cases.
Precisely. And this reminds me of another definition, another statement relevant to architecture by Ralph Johnson, one of the Gang of 4 people who was also very, very smart. And he said that architecture is about the important things, whatever they are. And at first it sounds like it's a platitude, but then if you start thinking about it, yeah, because there are different important things for different organizations, for different projects inside those organizations, for different teams. Everything is extremely contextual when you talk about architecture. And there's this figuring out what options you leave open and what options you close is actually a big part of the architect's role. You need to keep some of them open, but some of them need to be closed very quickly if you want to achieve your goals.
Yeah.
All right.
Simon
I'm curious
says,
to see what he says, about
so Simon says
upfront
here,
design.
some upfront design before you start coding. That's his answer to when teams ask, confused about how much upfront design they should do. Some upfront design before you start coding, and continuous evolution with design as you progress, learn, and deliver features. But some is very vague, and it depends. It's about the context.
Yeah, and I see the 6 statements.
So let's go through those. He says that perhaps a better approach is to think about upfront design being an iterative and incremental process too, and asking when should we stop doing upfront design instead. My view is that you should stop doing upfront design when: first, you understand the significant behavior drivers, requirements, quality attributes, and constraints. Second, you understand the context and scope of what you're building. 3, you understand the significant design decisions, technology, modularity, etc. 4, you have a way to communicate your technical vision to other people. 5, you are confident that your design satisfies the key architectural drivers. And 6, you have identified and are comfortable with the risks associated with building the software.
Right. I mean, it's a good list. The problem is, so let's start by saying, it's important to understand the significant architectural drivers, and this is, I would call those architectural concerns. Also, requirements, quality attributes, constraints. These are all important. I have a problem with the second one. You understand the context and scope of what you're building. From my experience, you will understand the full context and scope of what you're building only when you finish the project.
Yes. So after you built it, you know what you're building.
Almost anything. Even if it looks as if you know very well what you need to do, you will still have surprises. You understand the significant design decisions like technology, modularity. I'm not sure if understanding is the right word here, because you need to make some decisions. It's not enough to understand what are the decisions that you, and to make some decisions, you need to test them. This one is a bit vague for me. Then having a way to communicate, absolutely. Confident that your design satisfies the key architectural drivers. I'm never confident about that.
But you need to start.
Example that you need to start anyway. If you say that we need to have performance, let's make it easy. Response time for specific API endpoints to be less than a second. So I'm making this decision. It's a constraint. I'm designing the system so that it can work with this constraint. People will still implement the code differently, and we might have issues there. So I'm never confident that the design satisfies the key architectural drivers. Things will happen in time that they change this. And you have identified the risks associated with building the software. Yeah, it's important to have risks, and I would add threats as well. A good list of risks and threats.
Mm-hmm.
But do you know? I mean, you have identified all of them? Never. Something will come out, and when you don't expect it. It's so. I guess the list is good, but my general problem with this list is that some of the statements seem to be definitive when in reality things are much less clear than this.
Yeah, it's very difficult, I think, to make such a list.
Yeah.
It's almost impossible to make it in such a way that it's neither definitive but also quite clear to understand.
Yeah, absolutely. But he does mention a few techniques: workshops, interviews, event storming, impact mapping, domain modeling, OAD, CRC, DDD, architecture reviews. I don't know what ATAM is. Architecture dry runs, risk storming, concrete experiments for models, ADRs. These are all good techniques.
Mm-hmm.
So absolutely. I'm curious if he has anything on ATAM. I don't know what that relates to, but anyway. Right. I think another thing is he's talking about upfront design and kind of conflating it with architecture.
Yeah, because it's about probably upfront architecture. And
yeah, because I noticed that it's useful with when I teach the course to separate a bit architecture and design and talk about architecture as being a mostly strategic activity and design as being a mostly tactical one. But show also that they have, there's a large overlap between these two. There are things that are important. So, for example, if performance is very important for an area of your application, then the way you write the code in that private function in your module, in your class, is very important. So in that case, something that would normally relate to design, which is how I name my private method and how I write the code there, is actually influencing the architecture and is something that is more strategic than just tactical. But there are still many different parts for architecture and for design, and this is where I find this a bit I know many people conflate this, and I think it's a bit difficult to understand each other when we use these terms interchangeably. It's even worse when I hear things like designing the architecture, which technically is a correct term, but it makes everything so difficult to understand.
Yeah, because you can design the architecture and you can design the code as well. And code is design and design is code. So which one is design and which one is architecture?
Exactly. And I wrote a blog post at some point where I was proposing a different way of naming things, because design in English has two meanings. It's a process, but it's also a result. So when we talk about designing the architecture, it's a process of obtaining the architecture. When we talk about software design, is the result of the design, which would be the code, because that's, at least according to the XP way of thinking, the code is the blueprint. When you click build in your IDE, that's when the building actually happens, right? So you're just writing a blueprint for building a program. But this creates, at least for people who are not native English speakers, it gets a bit hard to differentiate between when you're using design as a process and when you use design as a result, and it gets a bit confusing. But anyway, I think we got. So, what do you think about these criteria?
I think it's a good place to start. I would refine them. I think we need more of these types of articles, analysis, and I like the idea of looking at how to stop something. So it's the same with, we can refactor some code and we could stop way too late. So I would prefer, instead of saying when to start refactoring, to say always, but more to say to ask the question when to stop refactoring.
Yeah,
it's the same here. Yeah, it's the same here. When to stop architecting, when to stop using test-driven development, when to stop using evolutionary design, because these are tools that are extremely useful up to a point.
Yeah.
And at one moment they become more costly than the benefits that they bring you.
So I guess a good conclusion to this is always know your goal before you start doing something.
Exactly.
And this is incredibly useful. This is something that I've learned by doing test-driven development, by practicing, and it has helped me tremendously. Now I'm asking for everything. Okay, what's the actual goal? What are we trying to accomplish? And there should be a single goal, a simple goal, and it should be achievable. And the second one, remember that every practice, every technique, every tool, every programming language has an applicability domain.
Mm-hmm.
It's meant for something. It's better at something, and it's not so good when you go out of its domain. Yeah. So one of my favorite questions to ask people who are promoting certain techniques is, okay, when should you not use it?
Mm-hmm. Exactly.
And I think we have some examples with, I think Thomas Sundberg and maybe even Liskio told us when not to use BDD.
Yes. That's a better question to ask. I think it's more relevant, and that's why I like this here as well. When to stop big design up front, or when to stop design up front. That's better.
Yeah.
When to stop design up front, that's a better guidelines or idea. So I really like this way of approaching this, rather than saying you shouldn't do design up front, because that's very confusing. Or you said you should do some design up front. Okay, but how much? Right.
Well, I think we got to a conclusion. Mm-hmm. Anything else you'd like to add?
No. That's fine. I really liked looking through this article, and it's it's a good one, I think.
All right. So, time to end. What do you think about this article? What do you think about these conclusions? What is your experience with design upfront and with big design upfront? Let us know in the comments. We are curious to find out. And if you have any other questions related to design, architecture, design upfront, some of the techniques that we mentioned, please let us know as well in the comments. As I mentioned a few times, we are planning to do a live event sometimes in September, most likely. So it would be nice to have you join live on YouTube and chat. But until then, it's been really great having you with us today. Thank you so much for watching. Leave us a like, a subscribe, a share, a comment about anything. And until next time, remember to think, design, and work smart.